Hey everyone, so for our FPGA final project, we decided to build the Turtle TPU, which is just a very simple implementation of the TPU V1 design by Google on our FPGA board. So here we just have a very simplified block diagram of what our design looks like. So first of all, it starts with the bootstrapper module. Our CPU is going to talk over UART and it's going to give it weights and instructions for the matrix multiplication operation, and it's going to load those in DRAM. We also have another buffer here called the unified buffer, which is going to store our input and output activations. Now, since this is a processor, we're going to be executing instructions, so we have a couple of stages in our pipeline which we see in our regular processor, such as the fetch and decode. So fetch is just going to fetch instructions from the DRAM, the decode is going to decode it, and then everything's going to drive this main computational unit here called the matrix multiply unit, which we'll talk about later. We need weight FIFOs to buffer like the weights as they come from DRAM, since there's variable latency there. And finally, we also keep accumulators here so that we're able to accumulate the results of our matrix multiply. And before writing the output activations back to the unified buffer, we can also pass them through like various activation functions. And I guess the main innovation of our Turtle TPU compared to a TPU V1 from Google is that it features this interconnect engine, which Ben will talk about.
The interconnect engine connects to another FPGA board, and primarily it's based on SPI, except it uses 4 wires, so it's quad SPI. It uses a standard data clock period of 100 cycles, and it uses a state machine to track the number of bytes you want to send to the other FPGA board. It takes in a source destination and a destination that you want your weights to be written to, and it reads from VRAM.
Yeah, so with this interconnect engine, this is going to let us do distributed inference, which we'll showcase later.
So at the heart of our matrix multiply unit is the systolic array, which allows us to do efficient matrix multiplication. The systolic array consists of an array of processing elements. Each processing element performs a single FMA operation, a fuse, multiply, add. So it will take in a partial sum from the top and an input from the left, and it already has a weight loaded inside of it. And then the output underneath will be the partial sum plus x times the weight. And if you arrange them in a grid like this and preload the weights into the systolic array, then if you put in a staggered input, x0 through x3, through the systolic array, then you will see that the sums that you get out from the bottom are the dot products between x and the column weights. And this allows you to do a matrix multiplication between the W matrix and the X vector. All right, now we will demonstrate our TPU on our FPGA. We wrote a custom MNIST model, quantized it to 8 bits, and we'll be running this short program in our own custom instruction set. And we'll run inference on this digit 2. Here we'll boot to the board. First we'll send our data, which consists of the weights and instructions, and then we'll get our result back. And you can see that we think it's the digit 2.
All right, so now we're going to demo our distributed inference. So as you can see here, we have 2 FPGA boards connected with a bunch of wires, and these guys are going to be talking quad SPI, and we're going to run inference on this input, which is like the digit 7. So on both sides of the FPGA boards, we're going to start booting.
Yeah, just.
And now we can see the output. So on both computers, we should see the same output, and it shows that it thinks it's the digit 7.